Physics 2211, lab number 5. I'm Hugh Spence. This is the Choose Your Own Adventure lab. I chose to sort of do a revisit of lab 2. However, this object has an initial boost upwards. So the purpose of this lab is to investigate how Newton's second law of motion could be observed. Newton's second law describes how an object at rest will remain at rest and an object in motion will remain in motion unless acted on by an external net force. So this can also be rewritten as the velocity update formula. So in this situation, the primary forces are as follows. There's the weight of the basketball, which is the force due to gravity, and there's the drag force on the ball. Moving into checker, this is our scenario. We can see our axis set up so that it leaves from the origin, heads in the positive y-axis, and then returns back down into the negative y-axis. And the calibration stick is set up as the diameter of the basketball. We run it, and we get the values down here and our graph over here. Moving into GlowScript, we have the ball's mass set up as 0.624, and we give it an initial velocity of 6.4 in the positive y direction. So this is our boost upwards. Now the delta t is 0.017. That's the frame rate. And we have our gravity vector here. Negative 9.8 is gravitational acceleration. We have a j-hat vector that's used for our drag. This is our drag proportionality constant. So right now we have it set up with drag to simulate the real world. Now here we apply our Newton's second law to calculate the drag force, net force, update the ball's velocity with our velocity update formula. We update our ball's position with the position update formula, and then advance the clock. Then we print our y values so that we can put these into Excel. So here we see the program run, the ball goes up like we do, and it comes back down. And we can see that drag gets bigger over time. That arrow gets bigger over time, whereas the gravitational force stays the same. We get this smooth curve, and our y value is down here. We can see the tracker values here in blue, and then in the other two colors, they're closely clumped together, but they're our computed values. So we can see that the tracker it reaches a smaller height than the computed values, and that's because in the real world we have more things acting on the ball. It's a stronger drag than what we compute here. Revisiting some of the things we looked at in lab 2, what is the effect of a boost on the terminal velocity? Now, this shows what a boost in the negative y direction does. And so if it was initially thrown downwards, the same terminal velocity would be reached. And that terminal velocity happens when the drag force is equal to the weight force and the net force becomes 0. So if given a long enough time to fall, the same object will reach the same terminal velocity no matter the initial conditions. Because it has the same object always has the same weight force. So no matter whether you give it a boost in the positive y direction like I did, or even a boost in the negative y direction, it's going to end up with the same terminal velocity.